Advanced Algebra 2 students, this is Mr. Hale, and these are your 12.1b notes. Now, I could give this section many titles. We're covering kind of a wide range of things, but I'm just going to call it Trigonometry 2.0. So we're going to take some of the things we saw yesterday and go one step further. So here we go. Let's do this. So the big idea again is that we're going to learn the reciprocal trig functions. We're going to find angles, and then we're going to solve triangles. We're going to do all that using trigonometric ratios, including the three we looked at previously. But let's go ahead and finish our repertoire of 6 trig functions. We're going to look at 3 additional today. Those 3 are the cosecant, which is the reciprocal of the sine function, the secant, which is the reciprocal of the cosine, and the cotangent, which is the reciprocal of the tangent. Now you have this in your notes. I think it's a good thing to consider. Each pairing of the reciprocal functions and the original 3 have one co in the name. Cosecant's the reciprocal of the sine, secant's the reciprocal of the cosine, and cotangent is the reciprocal of the tangent. We're going to start with a problem that looks very similar to the questions we've done previously in this section. It's just, you notice that it says to find the value of the 6 trigonometric functions for theta, not the 3 like we saw yesterday. Now, in order to find the 6 trig functions, we're going to have to find the hypotenuse. So we're going to do, again, Pythagorean theorem. 24 squared plus 70 squared is equal to the hypotenuse squared. I'll just call that side C. And with some quick use of the calculator, we find out that C is 74. All right, so let's go ahead and do our evaluation. We'll start with the 3 that we already knew, the sine of theta. From theta, the opposite 70, hypotenuse is 74. I'm going to go ahead and divide everything by 2. So 35/37ths, just to simplify the fraction. The cosine of theta is adjacent divided by hypotenuse. Again, we're going to divide things by 2. And then the tangent of theta is the opposite divided by adjacent. And once more, everything's divisible by 2. So let's clean it up. All right, those are the 3 we looked at prior. Let's talk about the new ones. The cosecant. The cosecant of theta is the reciprocal of the sine function. So you can go back here and say, okay, well, if sine is opposite over hypotenuse, cosecant's hypotenuse over opposite, and you could try to simplify from there, but quite honestly, if you already have the sine written down, let's use it and flip that fraction. We'll use the same strategy when we find the cosecant of theta. That's the reciprocal of the cosine. And of course, the cotangent of theta, which is the reciprocal of the tangent. That's all there is to it. It's so simple, I think we should do one more just to be sure. This is, of course, as you know, the best Pythagorean triple, 2099, 101, everyone's favorite. And we'll do this one pretty quickly. Sine of theta equals, and we'll have the opposite, which will be 99, divided by the hypotenuse. Cosine theta would be the adjacent, divided by the hypotenuse. And then the tangent is opposite over adjacent. I don't mean to be insulting when I ask you these questions, but we've got to find the reciprocal functions as well. So I'm just writing them out real quickly. Pretty simple stuff if you know what is paired with what. Let's keep moving on. Our next job is we're going to take a look at, if you know side lengths in a right triangle, how do you find the angles? So we're going to use something called inverse trigonometry, or you can see, like for instance, if the sine of theta is equal to A, then the inverse sine of A would be equal to theta. So if you know the relationship of the opposite and hypotenuse, you can actually find the angle by doing an inverse of sine. Same thing with cosine and tangent. Okay, and there's just a little thing down here to help you understand notation. And I should also point one other thing out. At times you'll see, depending on your textbook, you'll see a slightly different notation. This is what you see in our current textbook, but sometimes you'll see this as well, the arc sine. you'll see the arc cosine or the arc tangent. And all these are the same exact thing. There's literally no difference between an inverse tangent and an arc tangent, or an inverse cosine and an arc cosine. They are the exact same thing. It's just a different way of writing the notation. So again, that kind of depends on who the author is in terms of what you'll see. I want you to be okay with either one. I will probably work back and forth between the two because I want you to be used to using either and not rely on just one. Now, one thing that can be a bit of a misconception with the inverse notation, this -1 exponent, is that we would look at that and perhaps think, oh, sine to the -1, that means the reciprocal of sine, but it really doesn't. And that's a little confusing. I don't know what smart dude decided to make that happen, but he probably should have reconsidered that, or maybe somebody since then should change it, but I don't think we have that power. But anyway, the arc sine, arc cosine, arc tangent will work well as well. All right, so we're going to use those relationships, the inverse trig relationships, in order to find missing angles. In this case, they're all called theta, that Greek letter you all love. So what I have to look at here is I see I have an angle theta. The opposite side and the hypotenuse are the sine that I know, the sides that I know, which means that I know the sine of theta. So the sine of theta is equal to 26 over 47. Now I want to show you on the calculator how we make this happen. So I'm going to bring my calculator onto the screen here. First thing you need to do is make sure, again, that you are in degree mode. And if you're not sure how to do that, ask the person next to you, hey, how do I switch to degree mode? And get that fixed, because you need to make sure you are in degree mode. Now you see what I did, and I pressed it without talking, but I hit second and sine. Now I'm not pressing sine, and you can see that up here. I'm pressing the inverse sine. So I'm going to do the inverse sine of 26/47 and press enter. And I'm going to have my angle. I know theta right here is about 33 point, I'll go nearest hundredth, 59 degrees. Okay, for our next one, we have to determine again which trig function connects what we know and what we don't know. I'm looking for theta. I know the opposite and I know the adjacent side, so tangent of theta would be 13/15. And I'm going to go to the graphing calculator and we're going to do an inverse tangent. So again, it's the second in tangent of 13/15. And there we go, 40.91 degrees. Pretty straightforward, pretty simple, I would say. So, I mean, you got to know the trig functions, but once you do, the calculator work isn't too tough. All right, the third one here, we can see angle theta is right here, so we know the adjacent and we know the hypotenuse, so we're going to do the cosine of theta is about 34/71. Now I can tell you this is going to be close, not exactly, but close, slightly under 60 degrees. And I'm not cheating, so I better be right here. I haven't looked at it yet, but I know that this is close to 1/2, which means this is close to a 30, 60, 90. And oh, I think I said under, and by under I mean slightly over 60 degrees. So yeah, go by what I mean, not always by what I say, but you've learned that already. Being able to find missing angles in triangles leads us directly to our next topic, which is solving right triangles. Okay, when you see solve a triangle, what that means is find all angles and sides, all of them. Okay, now some of it's already given, like when I look at the first one here, I know I have a right angle. I don't have to say angle C is 90 degrees. And I know these two sides as well. I'm going to call this side over here lowercase c. It's kind of hard to tell the difference between lowercase c and capital C. And I'm going to use our old friend, the Pythagorean theorem, to help us out a little bit here. 39 squared plus 44 squared is equal to c squared. Now what I'm showing you folks is what I would consider to be the minimum amount of work that you should show on every problem. When you solve a triangle, I need to see a setup and I need to see an answer. Now sometimes you get these nice Pythagorean triples, like, you know, like everyone's favorite 2999 101 or 2099 101. I don't know what I just said there. Or perhaps you like 815 and the square root of 289. Oh yeah, that's 17. That's a good one too. But in this case, it's not. It's just 58.8 approximately, so we just go with 58.8. All right, we need to find some angles now to finish solving this. So we found the missing side. Let's find our missing angle. So I'm going to look at what's given to me. I know the two legs, and I'm going to use that information. I'm going to say the tangent of A is equal to 44 over 39. Now we just talked about, well, how do you find an angle if you know the trig ratio? Like for instance, in this case, I know the tangent to the angle. I use the inverse tangent. So inverse tangent of 44/39 tells me the angle A is about 48.4 degrees. Now, I will tell you there are a couple ways we could go about finding angle B. I think the one that I'm going to advise you to do is to do another step of inverse trig. Tangent of B is 39/44. Here's my logic on this. If you made a mistake somehow on the first answer, you will find that mistake if you pay attention when you find your second angle. Well, how would I find that? Well, I know this angle is about 41. It says right here it's about 41.6 degrees. And what we know is in any right triangle, the two acute angles should add to 90. Complementary is the word there. And those two angles are most definitely complementary. I'm confident in those answers. All right, let's take a look at our next one. First, I'm going to find side D, and I'm then going to follow that up with the missing angles. As a matter of fact, what I want to do here is actually give you guys a chance to find the missing side and the two missing angles. So pause the video right now, take a couple minutes, and find them. And then when you found the sides and the angle, or the side and the angles, replay the video. Hit pause now. All right, welcome back. You can see my work now on this problem. First of all, we had a nice Pythagorean triple. For side D, it was exactly 9. That's not a rounded number. It's precise. Okay, so what I did was I used the given information, the side lengths of 15 and 12, and I said the cosine of D is 12/15, and the sine of E is 12/15, and then I did some inverse trig on both. You can see the work on the calculator over here, and found my answers. That's all there is to it. All right, let's keep on keeping on. We're going to do a little bit of application work. Folks, you can see just a quick diagram to show you the difference between angles of elevation and angles of depression. Here's the big thing. Both are with the horizontal or the horizon, not the vertical. So in other words, you're never going to have an angle of depression where one side of the angle is a vertical line. It's always, 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 always going to be horizontal. So let's take a look at some applications that use this concept. Here's our first example of using angles of elevation and depression. Bow and arrow. Pretty good name for a guy doing archery, I'd say. But bow and arrow is practicing. He places a target 17 feet above the plane from which he's shooting. That doesn't mean the airplane. That means like the level of ground. Okay. And he shoots with an angle of elevation of 7 degrees. So I'm just going to kind of sketch the triangle to represent the situation. So there is that. And let's grab a pen here. Here we go. We know this angle over here is 7 degrees. And we know that he's 17 feet away. Okay, now how did I know where the 7-degree angle was? It says there's an angle of elevation. It's always compared to the horizontal side of the triangle. It's never over here. It's always with the horizontal. Okay, and this says what horizontal distance did his arrow travel? I've completely mislabeled my diagram. I was thinking ahead to the angle instead of dealing with the side length. You guys probably already caught this. Like, you're all yelling at me right now. But anyway, this isn't 17. It's 17 feet above. This is 17. This side over here, that's the side we're looking for. All right? That's all right. We all make mistakes. Sometimes I do them on purpose just to make sure you're awake. There we go. So tangent is 17 degrees. 7 degrees, excuse me, is 17 over x. If you multiply both sides by x and then you divide by tangent is 7, you get x as the tangent, or excuse me, 17 divided by the tangent is 7 degrees. And according to my calculation here, that gives us at about 138.45 feet. Now this one doesn't tell us where to round. Sometimes it will. You just have to pay attention to that. Do what's appropriate. Okay, then our next problem is going to use kind of a similar concept. We're finding angles of elevation, or using angles of elevation, I should say. So this time we have a surveyor who's measuring the height of a roller coaster. Okay, a roller coaster. I'm going to draw a really not so fancy roller coaster, but here's the loop on the roller coaster. Okay, and not drawn to scale will be the key thing on this. Okay, so the surveyor is standing on ground level, but his eyes, strangely enough, are above ground level, something like that. And he's measuring to the top. He sees there's an angle of elevation of 60.7 degrees. Did I mention this wasn't drawn to scale? Yep, not drawn to scale. Totally fine though. Of course, it might help if my horizontals were actually horizontal, but again, that's not really what we're measuring here. We're measuring heights, distances, etc. All right, so let's take a look at this thing. We know this distance here, this gap between the bottom of the triangle and the where the angle of elevation is going to happen is 6 feet. This is where basically where the surveyor is standing. His angle is 60.7 degrees, and as you can see, this triangle is pretty brutal, considering the fact that that angle looks to be about, I don't know, 20 degrees. That's all right. We know this is 120 feet from there to there. So what I'm going to look for, I'm going to call this X right here. You can call it whatever you want, but you have to remember that's not the full part of the answer. That's a part of the answer. And the trig function that connects the side we know to the side we don't know with this angle over here is the tangent function. So the tangent of 60.7 degrees is equal to X over 120, and I have X to be about 213.8 feet. Now, why did I say that's not the answer? Not just X, because remember how the surveyor's eyes are 6 feet above the ground? We need to add 6 feet to that answer. And it says to round to the nearest foot. So if we do 213.8 and we add 6, we're going to get 219.8, but it says to go to the nearest foot, so the answer we would mark down would be 220. Let's jump right into our next example. This time another appropriately named person, Southwest, is on her descent to the Johnson County Executive Airport. The tower informs her that she has 20,000 horizontal feet remaining, and she should travel with the 4-degree angle of depression to the nearest foot. What is the altitude of the airplane? So again, I'm going to kind of approximate the situation. This is the horizontal distance. The plane is hanging out somewhere up here, at least in this moment. It's not going to stay there long. But that's the situation right there. It says the airport says she has 20,000 feet remaining. Now it says the angle of depression. Now technically the angle of depression is this angle right here, 4 degrees. I would argue though that there's really no reason to mark it there. Why not just make our triangle like we're used to and mark it right there? These two angles, they're alternate interiors. So if I have alternate interior angles, they're congruent if the lines are parallel. So there's 4 degrees. There's the side we know. We're looking for the altitude. Okay, I'm going to use h as my variable, represent height of the plane. Again, the tangent function is going to come into play. As a matter of fact, it's probably fair to say that the tangent function is pretty commonly used in application problems because it's always the comparison of the horizontal side to the vertical side in either order. But the thing about it is that those are measurements that we frequently see. So this would be another one of those cases. And again, it does say to the nearest foot. This was about 1398 and a half. So we're going to round it to 1399. I just found the problem you guys have all been looking for today. It's the last one on your notes, so you can do this one before you actually get started on your work and do well. But a painter needs to lean a 30-foot ladder. Look at that. It's so nice. This is a nice drawing, isn't it? Excellent work, Mr. Hale. A painter needs to lean a 30-foot ladder against a wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be a quarter the length of the ladder to the nearest degree. What acute angle should the ladder make with the ground? So we're looking for this angle theta. It's that safety measure thing that comes into play. The distance from the ladder to the wall should be no more, or should be a quarter, excuse me, not no more, should be exactly a quarter. Well, 1/4 of 30 would be 7.5 feet. So honestly, all I have to do is look at this thing and say, well, what relationship is this? If this is theta, adjacent and hypotenuse are the two sides we know. So the cosine of theta is 7.5 over 30. A little inverse trig, inverse cosine is 7.5 over 30. And we get 75.52 degrees. All right, so that not the toughest problem to end you on, but a good one. Hey, folks, make sure you learn these relationships well. I didn't spend a ton of time on the reciprocal relationships, but make sure you know which one's paired with which. Make sure you know how to find missing angles and right triangles given side lengths. And as always, if you have questions, get help from your friends, your parents, your teacher, or anyone else who might know what's going on. You guys have a spectacular day, and we will see you soon.